Activity 5, Linear Regression. In this activity, you will learn how to use technology, which is Desmos, to find a linear function that models data that is not perfectly linear. Real-life data is often not perfectly linear, but if the data is roughly linear, a linear model is a reasonable choice for creating a model that approximates the data. It is possible to estimate the line of best fit by hand. However, using estimates can result in different people finding different estimated equations. When a calculator or software is used to find a line of best fit, a statistical formula is used. That means that all devices give the same linear equation, and it will be the one equation that best approximates the given data. This method is called the linear regression. The regression line passes as close as possible to all of the data points, so the regression line gives the best possible predictions based on the data. Your work in this activity will relate to several learning outcomes. The first one, you will be able to interpret the meaning of function values, slope, and intercepts. You will also describe the fit of regression equation to a data set. And you will work with tables, graphs, and equations using technology, using Desmos. And you will use Desmos to find linear regression line that best fits a set of given data. And you'll use that equation to answer some of the questions. And we'll start our class discussion with this problem. Number 1. The following data was collected by Rex Boggs of Glenmore State High School in Rockhampton, Queensland, Australia. Rex was investigating the relationship between time and the weight of a bar of soap. In this problem, you will use linear regression to model the weight of Rex's bar of soap in terms of time. We're going to use technology to graph the data. And here's the data from day 0 up to day 12 and the soap weight in grams. So go to Desmos.com. So this is Desmos.com and choose graphing calculator. And we're gonna need to enter our data here. So first I'm gonna add the data. So you don't need to do this. I just want to have the data on this page so that you can copy it later. So right. Okay. So we have the data here, day and soap. How to enter this data again? Remember from our last activity. So click on the plus button here, then hit table, and we just have to enter the data. So day, which is your x values, 0, enter 1, 2, 0, 1, 4, 5, 6, 7, 8, 9, 11, and 12. Then for your y values, soap weight in grams, 124, 121, 103, 96, 90, 84, 78, 71, 68, and 50. So when we enter all this data, as you can see, we don't see any points here. We learned this also from last activity, how to adjust the window. So you have to click on this, which is the graph settings. And you have the grid. We just have to change our x-axis and y-axis. So let's say we want from -10 to 10. So let's change this. Let's see. Change this from -10 to 10. Then you have to change the y-axis. Look at your lowest and highest here. This is what we did last time. We have the lowest 50 and highest 124. So maybe let's try from 0 up to let's say 150. And you will see our points here. So these are all the points, the data. 0, 124, so this is the first point. Next is 121, 4, 103. This one is 1168, and this one is 1250. So those are all the data. And as you can see here, let's go back here. The graph should illustrate that the data is not linear. How can you also use the data in the table to show that the data is not linear? If we connect all these dots, we can see. So if you press for 2 seconds on this color and then open the line, as you can see that it's not linear. So we cannot use that. And how do we check also from the table that the data is not linear? So remember our equation of a line, y equals mx plus b. Whereas the m is the slope and b is the y-intercept. So if 0 to 124 is our y-intercept, what do you notice about the slope of this? So let's say the first two. If you get the change in y over the change in x, 121 minus 124 is negative 3. The 1 minus 0 is 1. And if we divide that, negative 3 divided by 1 is equal to negative 3. Then let's check another. So let's say 5 and 6. 6 minus 5 is 1. 90 minus 96 is negative 6. So look at this. This is negative 6 over 1. And it is negative 6. Let's try another one. If I choose 9 and 11 and 71, 68, we subtract 68 minus 71 is negative 3. This one is 2. So this is negative 3 over 2. And they are not all the same. So they don't have the same slope. So this is not linear. Okay, so that's another way how to check from the table that it is not linear. They don't have the same slope. But we can say that, look at these points here. Isn't it roughly linear? Because you can imagine draw a line that looks like that, although those points are not exactly on the line. So but we can still say that this is roughly linear. Okay, now how are we going to find Desmos to find the linear regression equation for the data? If you go back to our discussion, we already have entered our data. We did graph it, and I showed you how to use a table to see if it's linear or not. And I showed you that we can say that it is roughly linear. Then letter D, use technology, use Desmos to find the linear regression equation for the data. And then use 4 decimals. So linear regression equation is in the form of this. Remember, y equals mx plus b. M is the slope, B is the y-intercept. So we need to get M and B. So how do we use that with our Desmos? So all you have to do here, click below the table and then type y subscript 1, because we want to use this y1 here. So type y1 equals, oh, not equals, sorry, it's tilde, it's next to 1 on your keyboard. So look for this key. Okay, then M for the slope, and then our x values, if you look at the table, is x1. Look at this, it's x1. So we want x1 here. So x underscore 1, then plus b. So that's the easiest way to get the line of best fit. And as you can see here, look at that, you already have the slope M and B, which is your y-intercept. So all you have to do is to type your equation, the linear regression equation. It should be in the form of y equals mx plus b. So type it here, y equals, your m is -5 point, let's use 4 decimals, 8779 x plus your b is 125.531, and that is exactly this line here. So this is our line of best fit. Okay, so when you try this on your own, I'd like you to, don't forget this. This is how you get the slope and B, your M and B. So you have to type this y underscore 1 tilde M for the slope, and then x underscore 1 plus B. Okay, so again, please don't forget. Try this, and you will be able to get your equation of the line. And then it says here, graph the equation, the linear regression equation. The line display should confirm that the data is roughly linear. So yes, when you type it, it's automatic that you will see the graph, and it's roughly linear because most of the points are on the line. Okay, let's go back to our questions. Here again we have our linear regression equation, y equals -5.7789x plus 125.531. Letter F, what is the slope of the regression line, and what does it tell you about the slope? So the slope is m, that is -5.7789, and that is the weight of the soap in grams per day. So it's negative, so remember our line earlier is like this, it's decreasing. So the weight of the soap, it decreases every day by -5.7789. Okay. Letter G, according to Rex's data, how much did the soap weigh at first? So at the beginning, what was the weight? So that is when, and click on this, when x is 0, you have 0.124. Or if you look at the data here, 0, 1, 2, 4. So that was the weight of the soap at first, 124 grams. According to the linear regression equation, how much did the soap weigh at first? So since we have this equation, at first, at the beginning, that is when x is 0, so we plug in 0 to the x of this linear regression equation. So y equals negative 5.7789 times 0 plus 125.531. And since negative 5.7789 times 0 is 0, so the answer here is 125.531. That is based on the linear regression equation. How do you answer part G and H, these two, differ? How much do you answer to part G and H differ? So here, this is 124 and this is 125.531. So if you subtract the two, is equal to 1.531. Sorry, this should be with 5. And the last question. Use a regression equation to approximate when the soap is gone. And to answer the last question, use the regression equation to approximate when the soap is gone. You could, this is for, sorry, I don't have a space. This is for letter J. So when it is gone, so meaning your y is 0, what is the value of x? So negative 5.7781 x plus 125.531. So if we subtract 125.531 both sides, so you will have here negative 0 minus that is negative 125.531 equals 0.57, sorry, negative 5.7781. X, and then just divide both sides by negative 5.7881. you divide negative 125.531 and negative 5.7881, you will get this. It's 21.6878. So actually, you can go back to Desmos and check it. So you can move this and look at that. Just click on the point that is on the x-axis, and we have that 21. Oops. Where is it? 21.356. That is when the slope is gone. Y is equal to 0. Okay, so that's how you get the you learned today how to plot the points. All you have to do is, just to recall, enter all this, and then you're gonna need to change the window settings so that you see all the points. So you click on this graph settings, you can change the x-axis and the y-axis. And then don't forget this, to get your m and b, the slope and the y-intercept. So y1 tilde m x1 plus b. So practice this, and you will be able to get your slope and b, m and b, to write your equation. Okay, and that's it for activity 5, linear regression. Thank you.